If you've ever stood in front of one of those giant video walls, maybe in a museum or a big corporate lobby, and it looks like one perfect image,
Yeah.
it feels like an absolute magic trick.
It really does. And that magic, that choreography, it all happens inside a very specialized box.
And today, we are opening that box. We're doing a deep dive into the hardware that is basically the ultimate digital traffic cop for these systems.
We are. We're looking at the Key Digital KD-VW4X4PROK.
So our mission here is to really strip away the jargon and get to the surprising features inside this. What is it? A 4K UHD4 input 4 output video wall processor and seamless matrix switcher.
It's a mouthful.
It is. But this thing is more than just a router. It's really an architectural tool.
It absolutely is. And just to set the stage, we are talking about high-end professional gear here. The MSRP is around $32.45.
Okay.
Though you can find it for closer to $29.50. And we should mention, there's a promo code out there right now, 10% off.
Good to know. Okay, so let's unpack this. It's got this dual identity, right? A processor and a switch. What does that 4x4 setup actually mean for someone using it?
It means flexibility. At its core, it's a 4x4 matrix switcher. You can take any of four sources.
Like a laptop, a camera feed.
Right, a streaming box, whatever. And you can send it to any of four outputs. That's pretty standard stuff for a high-end switch. But the real star of the show is the video wall processing. That's what lets you take one single source and stretch it across all four outputs to make one big composite image.
Okay, 4 outputs. But I saw that this thing can support up to 8 total displays. How does that work? You're not adding more ports?
No, and this is where it gets really clever. They call it dual video wall or mirrored outputs. So each of those 4 main outputs has 2 physical connections. Yep. A standard HDMI and a UHDoTP port. That's a ultra-high definition over twisted pair. Both of them show the exact same signal at the same time.
So why not just use a splitter? Is it for redundancy?
It's mostly about simplification and reliability over distance. An installer might use the local HDMI for, say, a monitor right there in the equipment rack.
Ah, for a quick check.
Exactly. And then use the UHDoTP to run the signal 100 feet away to the actual display wall. And crucially, the box comes with the 4 receiver units you need at the other end, the KD EXML VRX receivers.
Okay.
And they're powered by the main unit. It's called POSI, or Power over CCAT.
POSI power over CCAT, so you don't need a separate power adapter at the display.
No power bricks, no extra messy cables behind the screens.
That is a huge win for a clean install. A really big deal.
It really is. Fewer failure points, less clutter.
Okay, let's talk about the feature that, for me, just screams pro gear. Seamless switching. Anyone who's been in a meeting where the screen goes black for 2 seconds every time they switch sources knows the pain.
The dreaded black screen. This eliminates that completely.
Okay.
Well, a normal switcher has to, break the digital handshake, re-authenticate the copy protection, figure out the display info all over again.
Every single time.
Every time. This processor, it holds onto the old signal until the new one is fully buffered and ready to go.
Yeah.
So the transition is, well, it's seamless, instantaneous.
It just makes everything feel more professional, more fluid. Essential for like a live broadcast or a command center where you just can't have that interruption.
Exactly.
So that handles the digital headaches. What about the real world physical headaches? Actually mounting these screens and making them look good.
Yeah, that's a whole other challenge. So first, you get 5 different layout options, 5 video wall modes.
Okay.
You can do the classic 2x2 grid, or a super wide 4x1 banner for signage.
Yeah.
A 3x1. You can even do 2 separate 2x1 pairs or a vertical 1x4 tower. It covers most common setups.
But the biggest physical problem is always the bezel.
Yeah.
The plastic frame around the screen. You line them up and you get these thick black lines cutting through your image.
And that's where bezel compensation comes in. Think of it like intelligent cropping. The installer can go into the software and digitally remove pixels from the edges of the video feed, top, bottom, left, and right.
So the image effectively jumps over the physical plastic frame.
Exactly. That content is stretched just enough so that your eye sees a continuous image flowing across the whole wall. It visually hides the seams.
How much easier is that than trying to fiddle with the menus on 4 separate monitors?
Oh, it saves a massive amount of time. You're doing it all from one central interface instead of trying to perfectly match settings across, 4 or even 8 different screens.
And this leads to my favorite feature, the one that sounds completely backward at first. Panel flip. Why on earth would you mount a display upside down?
This is such a brilliant installer hack. It's often for when you have to use, say, consumer-grade TVs instead of professional panels.
Because consumer screens have that thicker bottom edge, right? For the logo.
Exactly. A big chin at the bottom. So panel flip lets you physically mount the top row of displays upside down.
So the two thinnest edges, the tops of all the displays, meet in the middle of the wall.
Right. It dramatically reduces how thick that center seam is. It just looks so much cleaner.
That's very clever. But I have to ask, for a piece of gear that costs nearly $3,000, isn't that feature sort of enabling the use of cheaper, non-professional displays?
That's a fair point.
Yeah.
But you have to look at it as, giving the installer the maximum number of tools to solve real-world problems. Sometimes the budget dictates the displays you get. This makes the best of any situation.
A practical solution.
Very. And speaking of practical, there's also a text overlay feature. So you can display the name of the source right on the screen, which is super helpful for diagnostics.
Let's shift to performance. We're talking 4K, but there's a really important nuance here between the inputs and the outputs.
Yes, this is key. The inputs can handle a 4K signal at 60 frames per second, but with 4.2.0 chroma subsampling.
Okay.
The outputs, on the other hand, deliver 4K with full 4.4.4 chroma, but at 30 frames per second.
So you're trading half the frame rate to get full color information. Why is that a good trade?
Because for most corporate or digital signage uses, it's the perfect trade. That 4.2.0 subsampling can make fine text or lines in a spreadsheet look a bit blurry.
I see.
By dropping to 30 frames per second, which is perfectly smooth for presentations, and boosting the color to 4.4.4 to get razor-sharp text and graphics, it's prioritizing clarity over, say, high-speed gaming motion, all while staying HDCP 2.2 compliant, of course.
Makes sense. Now, what about distance? How far can you actually run a cable from this thing to a display?
Using that UHDoTP for a full 4K signal, you can go up to about 35 meters, that's 115 feet, with standard C8T5E or the TT6.
And if you use better cable...
With a shielded 8.6A cable, you can push it to 40 meters, or 131 feet.
And what if you're just running an older 1080p signal?
Then the distance really jumps, up to 50 meters, 164 feet on standard cable, and even 60 meters, almost 200 feet, on the good stuff. It covers almost any room you'd put it in.
But there's a weird catch, right? A minimum cable length.
Yes, it's a little counterintuitive. You need a minimum of 5 meters of 17 feet of CT cable for any resolution.
So you can't just put the receiver right next to the matrix with a tiny patch cable.
No, the system needs that length to properly stabilize the signal and negotiate the connection. It's an integrity thing.
Got it. And what about audio? We've only talked video.
Audio handling is really robust. It has audio de-embedding.
Meaning you can pull the audio out of the video stream?
Correct. You get 2 ways to do it. There's a 6-pin connector for professional balanced or unbalanced audio to go to a mixer.
And the other?
A standard digital optical port, a TO-Slink. And it handles everything up to 5.1 Dolby or DTS surround sound.
And for older systems, I saw it has a 4K down convert feature. That seems huge for retrofit.
It is. You can feed it a 4K source and it will cleanly scale it down for older 1080p or 720p displays you might have elsewhere in the building.
Okay, so a lot is happening inside this box.
Okay.
How does it stay stable? What keeps it from crashing?
That comes down to what Key Digital calls their full buffer system.
Yeah.
It's the backbone.
Let's break that down. What's that really saving me from? Yeah.
It's saving you from glitches and signal dropouts. It does 3 main things. First is TMDS reclocking. That basically cleans up and regenerates the signal so it can travel those long distances without degrading.
Okay.
Second, it manages all the HDCP authentication. That's the copy protection handshake that, when it fails, makes your screen go black.
The bane of every installer's existence. And the third thing.
The EDI handshake. That's the conversation where the source and the display agree on what resolutions they can both handle. The buffer system manages that negotiation so you don't get those unsupported signal errors.
So it's basically the system's internal diplomat, making sure everyone is talking to each other correctly.
That's a perfect way to put it.
And how do you, the user, control all of this?
The options are really flexible. You've got your basic front panel buttons, old school IR and RS-232.
Standards.
And of course TCP/IP. That lets you control it over the network, which opens up the really nice web UI. You can just pull it up in a browser and manage everything.
Does it play nice with bigger control systems?
Completely. It's Key Digital app ready, so it works with their software right out of the box. But more importantly, it has an open API, so it can be integrated into pretty much any major third-party system out there.
And for the installer on site, I saw it has built-in test patterns.
Yeah, that's a great little feature.
Yeah.
9 different screens you can call up to test your cables or check colors without having to plug in a laptop or some other source. It's a real time saver.
It really feels like a complete package.
It is.
So when we wrap this all up, what does it mean for you?
We started by calling this thing a traffic cop, but it's clearly, it's so much more. It's an architectural tool. It solves the digital problems with that seamless switching, and it solves the physical problems with clever tricks like bezel compensation and panel flip. It's all about making sure that final image is perfect.
And if we look at the really big picture here, there's one last spec that says everything about who this is for.
What's that?
The device is TAA compliant.
TA, explain that. It means it meets the standards of the U.S. Trade Agreements Act. Basically, it certifies where it was manufactured, which is a requirement for a lot of government contracts.
Ah, so this is cleared for government or military installations?
Exactly. For enterprise, for government, for any high security or high stakes environment. That TAA compliance, on top of all the performance, is a huge deal in that world.
So the next time you see one of those flawless video walls, in a stock trading floor or a government command center with no glitches and no seams, just remember there's a very specialized, very intelligent, and likely TAA-compliant box like this one working tirelessly behind the scenes to make it all happen. You're probably looking at the result of exactly this kind of powerhouse architecture.